Hello, everybody. My name's Aid, and I'm going to talk about a project that we've done in Gilt, which was to bring keyword search to the Gilt shopping experience. I'm going to tell you what Gilt is in a moment, and in particular, I kind of want to call out, why doing search at Gilt was perhaps a little harder than most e-commerce shopping experiences, and then talk about the kind of problems that we had, and talk about then how we solved all those problems. Okay, some of the solutions are really neat and really nice. Some of the solutions are actually hacky, right? We don't like them, right? So one thing I'd value is if you have any ideas, or any corrections or whatever, that would be really, really great. Okay. The other thing is I'm going to give you all $25 each. That's not $25 across all of you. I'm going to give you all $25 individually, right? There's a subliminal message in one of these slides, and if you spot it, you can get $25. Okay. So now you're all watching, huh? Now you're all watching. Okay, so most people in Europe, so myself, my name is Aid. I used to work for a company called FuseSource, and we specialized on service mix and Camel and ActiveMQ. And I also, as part of that, became a committer on Apache Carafe. And over a decade as a consultant, this was my map, right? So it was kind of cool. I traveled quite a bit, okay? And my map has gotten a little smaller over the last year and a half since I joined Gilt. Let me tell you what Gilt is first. So, in a nutshell, Gilt is all about exclusive, gorgeous stuff, right? On sale now, right? In particular, on sale at noon, okay? It's the flash sale model. So when I was asked to join Gilt, they were like, oh, it's all flash sales. And I was like, I don't want to use Adobe, I'm a Java man at heart, It turns out the flash sale concept is this idea of, okay, we have handbags, right? They're Louis Vuitton or some kind of, really posh handbag, right? They're last November's handbags. We have 100 of them, and we want to get rid of them. They were $5,000, but we're going to sell them for $600, okay? And the way we're selling them is it's first come, first serve. They will start being on sale at noon on Monday, and the first, couple hundred people, they will get the handbag. Okay, so very, very simple concept. And when Gilt started originally, we had a lot of connections through a lot of the design houses and a lot of the manufacturers, particularly on the eastern coast of America. So we ended up getting all of these great deals, and in a sense, then Gilt grew in a viral way. Okay, but one of the key things about Gilt, I guess, is it's all about the stampede. Right? It's fundamentally different, right? It's literally people getting ridiculously, overwhelmingly excited about the fact that a brand they love is available at a really neat price, okay? And in that stampede, then, people do silly things that they wouldn't normally do, like they actually buy stuff, right? They actually go, oh my God, if I don't buy it now, then I'll lose it, So literally, we end up with a stampede on our site every day. Okay, and that stampede comes in through the website itself. It also comes in through mobile, through iPad. We have tons of apps and things to let people get access. Okay. Started off predominantly women's products. Then we went into men's products as well. So tons of stuff around that. Okay. Then we went into babies and kids. Right, so maternity and loads of stuff for kids, and again, like every day, the website has changed. Every day, there's a new sale, there's new product, there's new stuff, right? We also diverged into home. This is actually quite cool. This is today's front page, and it's inspired by the White House, so it's very topical, One of the key themes amongst all of the merchandise is it's low quantities of luxury product, right? Very highly branded luxury product, okay? We started selling burgers and steaks as well, the finest burgers and steaks that you'll ever eat, and also fine wine, and in general, everything that like the foodie would want, absolutely top-class food. So that's the Taste website. And then we went into City as well. So City is really about, awesome things to do in your city. These are kind of like events. You could say, isn't that a bit like Groupon, right? But, it's like, Groupon or whatever, they might sell you, tickets to go to the cinema, right? Well, whereas City would sell you tickets to go to the opening premiere, you know, and have dinner with the director afterwards, right? It's kind of like a level up in terms of what they're doing. So that's Gilt City, and then Jet Setter is travel all over the world, just absolutely awesome hotels and places to stay all over the world. Okay, so that's the kind of the whole, you know, the Giltosphere. Okay. And like I say, one of the key things, I think that makes it particularly interesting for me, because I mean, I used to sell middleware, or rather consult on middleware, and all of a sudden I'm selling handbags, right? I have no interest in handbags, right? I have no interest in handbags. I said that to the camera for future reference. But the thing is that what's really interesting is the attack of self-denial. Actually, the color here is a little bit too light, but this is kind of time on a given day. This is like, you know, 10 o'clock, this is 11 o'clock, and then all of a sudden, you know, at about 10 minutes to noon every day, all of the push notifications on mobile, all of the SMSs, all of the emails go out to our millions of members, and then they come to the site and it just shoots up. It's absolutely massive. So at noon, it's a massive rush, and then it kind of eases off over the rest of the day, and then it kind of goes down to a steady state. Okay, so you can imagine there's some really interesting engineering problems there. Okay, the subliminal message. Okay, so we created a little promotion for you. If you go to that URL there, and if you join up on Gilt, your first order will have $25 discount. Okay, so I'll show you that slide again at the end if you want to give it a shot. Okay, so no need to take it down now. Okay, so just a little note about Gilt Tech running the whole site. Headquarters is in New York. I come from Dublin over there, and then Portland, Oregon is also one of our development centers there. There's about 100 engineers in total across all the various parts of the business, including warehousing, operations, the site itself, mobile, all these various areas. Okay? And so here we come with the problem, okay? And actually, the problem is really, for me, I thought really interesting, because when I joined Gilt, and when I started shopping on Gilt, and when I started looking for stuff, there was no search box, right? And I found this like really crazy. I was like, you know, what year is this? Is it 1993 or something? Or actually, the web wasn't even around in 1993. You know, it's like, how can you have an e-commerce site without a search box? And it was really interesting because organizationally within Gilt, the people, you know, the merchandise, the execs, everybody believed that it was all about the stampede. And it was more about the stampede than anything else, okay? So basically, people don't come to Gilt to search for stuff. They just come to Gilt because there's going to be exciting products given to them, right? And I believe that is definitely the case. It's still the case. But I kind of came with the aspect of, you know, regardless of all that, people still want to search for stuff, right? I have this hankering that when I go to any site, my eyes shift immediately to the top right. I'm looking for that box. I really want to have a search box, okay? So, so it's funny, I kind of said, is there any reason why we do not have a search box? And it turned out, you know, everyone was just like, no, I don't know. So I said, okay, well, let's actually do search, okay? One of the warnings, or one of the things that people said was, it's going to be really tricky for Gilt, right? Why will it be tricky? Well, it'll be tricky because of a number of things, right? There's a lot of product, right? But there are small quantities of the product, right? So examples of this, we might have only one airplane that we're selling today, okay? For example, we did actually sell the naming of an airplane, okay? I think it was for something like $60,000, right? And it actually sold. Who knew, you know? So we sell sometimes like, you know, one very big product. We might sell a dress, but we only have it in sizes 0 and 00 and 10, but we don't have it in sizes 2, 4, 6, and 8. Okay, so there's a certain sparsity in some cases. And then the quantities may be low, so you know, in those first couple of seconds after noon, when all the product goes live, bang, it could be gone, right? And one of the worst possible experiences that you could have is searching for something, right, and seeing it there in the listing, but seeing that it's sold out, right? And that would be the worst thing ever, right? What we do know about when people purchase is that when they see a listing of products, you know, they read from the top left, right, and then they go down the listing, right? And what our merchants do is they put the sexiest product, they put it at the top in the left, okay? And naturally, that's going to sell out first, right? And then when people come to the site, they'll go, oh, everything's sold out, and they won't scroll down, right? So we need to make sure that we always keep this sense of freshness, and we make sure that, that people can always see available product, okay? So in order for you to understand some of the problems, I have to explain the data model and introduce you to the haiku that I wrote yesterday. I've only written one haiku in the last decade, but I think it's actually really good because everything I've seen about doing relational data in Solr is just hard, right? I've heard of people doing block joins and join queries and all these things about trying to and whatever nested queries and everything, and it just seems so kind of complicated, And ultimately, I think like every e-commerce company, we have structured data, right? That's the way it is, right? Relational data. So one of the things, and you'll see it in the solutions, we basically just denormalized everything, right? And I'll talk about what that means in a second. So we've got products. For example, the silk charmeuse wrap dress. That's the idea of a product. It's got the product description. It's got the country of origin, the usual types of information about a product. Every product can have a number of looks. We call it a product look. So that product could be available in leather, in black. It could be available in cotton, in red, or cotton in blue. So the look allows us to give extra attributes, typically mostly around the idea of color. And then at a SKU level, the stock keeping unit, we have the size. Typically, that's just the size and perhaps some additional SKU attributes. Okay, so I think this is a really kind of common kind of pattern to have, right? And clearly, there is one-to-many written all over this. Okay. So then the other thing then is we have a sale. A sale starts at a particular time, usually noon on a particular day, and it lasts for probably 24, 48, or 72 hours. Okay, so a sale is really the availability of a bunch of SKUs for a period of time. Okay. And kind of the timing is important. It's all about the rush. So one of the things that's really interesting and kind of like really interesting for us was, so a sale or product, a sale goes live at noon. It cannot be available in the search index before noon, right? Because if people discover that they can get access to the products and the prices of those products before noon, right, well, then they've kind of found a backdoor in, right? So we need to make sure that the entire search index effectively goes live, bang, at noon, right? So, and that was really interesting. It was a really, really interesting problem. And I'm going to talk about, how we did that. Okay, so here's the architecture of the solution. It's interesting. We kind of knew that we wanted to do this architecture at the start, and it turned out that it played out exactly this way. Okay, so I just want to talk to you about some of the key parts of it. I'll start in the middle. What we have, or no, I'll start over here. So client makes a request. We're a big Scala house at Gilt, so we decided we would use Play Framework. And it turns out Play Framework is really, really fun to use, really, really neat. So you've got your usual controllers. And what happens then is we've built a little search API, again in Scala, but with a very, very nice Java-friendly interface, so there's no problems at the edges. And ultimately, that kind of sends the request to Solr, right? So Solr's, Solr, it's got a Lucene index inside it. We've got some extra plugins and components, which were the bits that we developed to make it all work for us. But the interesting thing, I think, and it was something that I struggled with at the start, was what should I store in Solr? And we've heard these ideas of using Solr as a storage mechanism, like a NoSQL database. And we decided that every part of the architecture should do one thing alone and one thing well, right? So all we ask Solr to do is produce an index, right? And the responses then are simply the IDs of the looks that match, and then for each look ID, right, what SKUs match that query, okay? And that's the approach that we've taken, okay? So we don't really store any data at all, bar the look ID, the SKU ID, and you'll see later the sale ID as well. That's all we store inside Solr, right? And turns out I'm pretty happy with that. I mean, it worked out really, really well. Our index is quite small. When responses come back, we enrich the response. So we enrich or we hydrate. So we take the look ID, and then we get the product details, all that kind of stuff, bundle it up into some JSON, lash it out through some controllers, and then away it goes to the browser for rendering, okay? And we do a mix of client-side rendering using handlebars, but we also do rendering in the Scala templating language, the Play Framework templating language as well, okay? I'm not sure if everyone is doing this kind of architecture. You know, I kind of sense that people are moving towards using Solr for storage, but we stayed well clear of it, and actually we're really happy we did. I think the reason why we did that is because we already have a data model inside Postgres for our products. We're also possibly going to move a lot of that into Mongo, right? And then having another place, Solr, for an unstructured or schema-less kind of content or description of what a product was, just started smelling of all manner of hell. You know, like, where is the data? What structure is it? I don't know. Depends where you get it from. We didn't want that at all. And so there's a couple of services then that are used underneath this. I'll explain how these all work to get everything working. Okay. So the minimum viable product, what were we doing? Search listing of product looks. The solution to the inventory problem is you always move inventory to the bottom of a listing if it's sold out, okay? So the question then is how can you tell in real time whether the product is sold out or not, okay? Because you can't index that data in real time. It's just not possible, okay? The usual faceting requirements, wanted to be able to search over the different stores, home, women's, taste, men, kids. Targeted search results was really important, right? So we have this idea in Gilt of our special elite members, they're the noir members. And for those guys, we'll create a special sale, and nobody else is allowed to see it, right? So this might be, you know, next year's Burberry collection, you know, specially for our best customers, and nobody else is allowed to see it, right? And when we do like a sale like that, it's specifically targeted, right? So what we need to do is make sure that if one of these noir customers comes into the site, right, and searches for Burberry, they'll find Burberry, okay? Brilliant, okay. But if somebody else comes into the site, then they won't, okay? So we have targeting based on customer groups. We have targeting based on geo-IP location. So if you're coming in from a warm state, then we might want to show you or boost certain products around like sun chairs or light T-shirts. If you're coming in from Alaska, we probably want to target sales that have big, heavy winter coats. So we want to make sure that, you know, each listing is personalized or is targeted, okay? And so that turns out to be something that, you know, we needed to make sure that Solr would support that, okay? As I said, we've got to maintain the concept of the start time and the end time, right? So a product can only be available in a listing if the sale is live. And then typically as well, you know, your usual favorites, auto-suggest and auto-complete. Okay, so let's talk about the search space. There's so much stuff that you could index, right? And we made, I think, every mistake in the book when we did this, because actually we'd never actually built a search index before, my team. So we were like, you know, yay, let's go. And I'm going to show you some of the big mistakes we made. So some things are really obvious and good to index. Taxonomy, for example, this is in chairs and ottomans. The brand name, you can see it up there. The product name, these are all classic things that you'd want to index. The price, because you want to be able to sort on price. The color, which is a nightmare. And I'll talk to you about color in a second, because I think it's really difficult. It shouldn't be, but it is. The inventory status, whether it's live or not, and the description, right? And this here, the description, is a can of worms, right? It is possibly one of the worst things that we could have done. It feels obvious, right? You know, if there are words in the description, then we should add them to the index. And it turned out to be a really bad idea, right? And I'll tell you why in a second. Other things as well, the actual SKUs itself have attributes like leather, like cotton or whatever. So we add those into the index. Attributes, material, and also the origin, what state they come from. So there was all this possible stuff to index, right? And what we discovered really is that the data is a total pain in the ass, right? We have so much data from so many merchants who are uploading it all using a tool called Excel, and they're just throwing all sorts of stuff up there, and that can introduce lots and lots of mistakes, okay? Lots and lots of unexpecteds. So, example, right? So we had like, in some of our first searches, I was looking for like a black leather bag or something like that. And all of a sudden I was seeing green leather bags, right? And that's because the description contained also available in blue, black, green, and leather, okay? So basically the description was kind of like at the product level, had all the information about all of the looks, right? And so it was completely indiscriminate. So what we got was great precision, but really poor accuracy, and that was a real distraction, okay? Colors are often really poorly named, like BLK is an abbreviation for black, black, priest, black or white, night, 100 multi-patent. Like we just had every bad color in the book, right? And I'll show you how we got around a lot of that. We have a reasonable solution to that, but it's not a great solution, and there is a better solution that we can work on, okay? I think it was Mikhail this morning brought up this issue of polysemy, and we have exactly the same problem. So we sell Thomas Pink shirts. I searched for pink shirt today, and I got that lovely black shirt, which happens to be Thomas Pink. And the other thing today, which is great, I mean, I just was playing, and I searched for white dress, and I got this lovely white dress. It is white, goddamn you. It is white because the brand name is, White and Wallander or something like that, right? So there was white in the brand name. So, so basically, I think the thing to do if you're building a search solution is try your hardest, throw something out, and then learn about why it is creaking and smelling. And then you've got to, I guess, come up with ways to fix it. One of the big things that we did at the start, and again, we thought we were really great because we wired up the Princeton synonym library. I think you can do that pretty straightforward with Solr. And then we thought that would be really, really great. And it turned out then we were getting handbags. And actually, it wasn't even a tanned handbag. It was like a raspberry handbag, right? So, you're like, my God, you're presenting to the execs, on your company, and you do a search for a black dress, and you see a handbag, right? So clearly there was something wrong, and it turned out then that this was what was happening, for anybody you can see down here. So black was synonyming to jet black was synonyming to jet, right? And then dress was synonyming to the verb set, right? So the query, black dress, was moving to a jet set, right? And so it was matching on that. Solr's query analyzer is really useful to help out with this kind of stuff, okay? But it was painful. We ended up taking out the synonym database. I used the word synonym leakage there. One of the other things I've seen as well that can be, synonyms look like a really great idea. If they're configured wrong, they can work transitively, right? So basically, it's not that something is a direct synonym of what you're looking for. It's that it's a synonym for a synonym of a synonym. Okay, when that starts to happen, you just get these, really crazy experiences. Okay, so the first question we had was, do we index by look or by SKU, right? Because our listings have looks in them, right? You want to show the T-shirt in blue, in red, in black. Okay, you do not want to show the same T-shirt 12 times in the same color because it's in 12 different sizes. Okay, so we started off saying, okay, let's try and do index by look, right? And then have a multi-valued field which would have the size, okay? And this seemed like a good idea, but actually it turned out to be really, really bad, okay? The reason it was bad is because if you were to do a filter and say, I'm looking for medium, it would give you all of the products that exist in medium, right? But those products could actually be sold out. Okay? So that creates a massively disappointing experience for the user. It's like, oh my God, you've got my favorite black T-shirt, and you have it in medium, and you click on the page, and then you go, but it's not available, right? And if you do that once, it feels really bad. But then when you go, okay, I'll look for size 12 Converse in black, right? And then you do that, and you go, great, you have them, they exist. And then you click on it, and you go, oh no, it's sold out, right? And there's only so much of that sold out experience that anybody can really go through, okay? So we needed to get away from that. So what did we do? We denormalized. As per my haiku. We indexed by SKU with a single valued sized field. So every document is a SKU, and there's one single value, which is the size. Okay? And now when somebody indexes by M, right, they only get the SKUs that match, which is great. This is exactly what we wanted, okay? So that turned out to be really, really good. Of course, we list looks, not SKUs. So as a result, we used Solr's grouping mechanism. It's called grouping or field collapsing, right? And that worked out really, really well. Now, it actually turned out to be really interesting because we debated using this mechanism for about 5 days. Oh, will it be slow? I don't know. Maybe it won't. God, it could be fast. I don't know. What do you think? You know, round and round in circles. And then we just said, screw it. We'll just do it, right? And then we'll see how it works, right? And it turned out it worked absolutely fine, right? We were so worried about it, you know, like all of that grouping and blah, 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 and actually turned out to just work absolutely fine, okay? So premature optimization is the root of all evil. We may have something down the bottom here. We may move to using block join queries, right? But I don't know. It just looks terribly complicated, and we certainly don't. I don't think we need to right now. So if you look inside Solr, the first thing we're doing, dead easy, we're enabling grouping, right? And it works a treat, okay? So that's the first thing. I have 5 of these slides that show how we built up our solution within Solr. So the real-time inventory ordering, how do we do that, right? So we didn't even attempt to encode the inventory status into the index. Because at noon, the inventory status of any product is changing so fast, bang, 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 that you just can't index fast enough, okay? So what we did was this, right? We have in Gilt, we have an API that allows you to get the inventory of a given SKU, right? Now what it does is the caching API, when you start up this inventory client, it basically pulls in an optimized blob of data that says, here is the inventory status for all of the live inventory right now. Okay, that's the inventory client. And once it has that blob, it then listens over RabbitMQ for updates. So basically, you know, each instance is being updated live with the latest status. Okay, and you have this really, really simple API there. Okay. So then what we did was we said, okay, we'll create a custom function in Solr, which is inventory. Okay. And that inventory function in Solr is basically really simple. It assigns a numerical value, 0 or 1, depending on whether that item is available or not. So if I get a list of 900 matching SKUs, I run it through that inventory function, and each SKU gets matched to 0 or 1, okay? And then I can then sort, okay? And that turns out to be just really simple. So order by the inventory status of the SKU, and then after that, use the score. Right? And that basically pushes all of the sold out SKUs to the bottom, okay? And that works out to be really, really good, okay? I threw this in really just, you know, this is like a snapshot of the code. I gotta say, since I've become a Scala programmer, I don't like this whole Java thing anymore. But I would say, like, when you're doing these plugins for Solr, it really isn't a friendly API. There's an awful lot of messing around, you know. So nonetheless, though, what's great is the framework is there. So when you figure that what you really need to do is not extend a function, but extend a value source. What the hell is a value source? I better go look up all these mail archives and find out what it is. Eventually, you get down to the right thing. And basically, this was a snapshot of the code. So that's how we do the ordering. And so our diagram looks a little bit like this now. Solr, our runtime, is periodically pulling the data from the inventory service. And then we've got this inventory function, which is being used by the sorter, right? Which is then grouping. And that's giving us then all of our search listings correctly ordered with the sold out stuff at the bottom, okay? And that's really great. Cool. So targeting and personalization, how did we do this? So sale targeting, this is what I was saying earlier about the idea of having different groups that see different products, and maybe in different locations there are different promotions being targeted, right? So all of our search listings and our auto-suggest has to respect this, okay? Because, you know, yeah, if I'm not allowed to see the Burberry sale, then basically, yeah, it shouldn't even be suggested to me, okay? So how do we do this, right? Well, what we do is we store the sale ID. So every SKU is active because of a certain sale. And then we pass the user's GUID into Solr as well. And then we have a method that basically is able to say, is this user GUID, allowed to see this sale? Okay? That uses cached data about groups, right? And again, optimized data structures to store the grouping information. And ultimately, we've got a custom filter then that just removes SKUs for this user. Okay? Now, this was a real risky area of the project. We didn't know if this was going to perform well. It turns out, because all of the data is cached, it turns out that it works really, really well. So we're doing well. We have this targeting filter here, so any search is being filtered by the current user. Okay, so this is like fully kind of personalized, targeted search, right? And it turns out it performs really well. We're really pleased with it. Okay, so timing, the time sensitivity issue. How do we deal with that? Okay, so the sales go live at noon, and we only want the products to be visible on search within that time. So we index Solr every n minutes, where n was arbitrarily chosen to be 15. But we certainly can't index Solr every second, okay? That's just not going to work, okay? So how did we encode time into the index, right? So here's the first idea. The first idea was, so when we're indexing, create some dynamic fields and say, this SKU is available in whatever store, home or men's or kids, at this time. And it ends at this time here. Okay, so every SKU has encoded in it the time it starts, the time it ends. And that means then for every single search, we filter and we say we're only interested in SKUs that are available from star to now and from now plus 1 hour to star, right? And it turns out then that basically filters in the set, okay? Calculating that query over the entire data set on every time would have been a disaster, okay? And so, all praise and thanks to the chump. Is the chump here? Is Chris here? There he is, there he is. So it turns out, I asked this question of the chump in Lucene and Revolutions in Boston, and he answered it almost immediately. So based on the back of that answer, I was able to justify the entire trip to my boss. You know, this saved us hundreds, thousands of dollars, you know. I could expense champagne on the back of this advice. Basically, filtering by time for every request is expensive, okay? So the solution is simple, that what we do is instead of having star to now, we round star to now/hour, right? And that basically says, go from time to, let's say, 15 minutes past 11, rounded up to the next hour, so to midday. What happens is then is that this is cached, and that cache will be valid for at least an hour, right? Now, it doesn't have to be an hour. You can do it for a minute if you want as well. And like sales start on the minute or on the hour, right? So actually, it turns out this is perfectly valid, but what it allows is it allows Solr to cache the filter queries, okay? And this turns out to be just absolutely brilliant. So absolutely aw-chump, okay? Now, time-sensitive search, okay. So what happens now? So basically, this is just an example of how it would look. Every SKU, if it's available in the home store, that's the start time, the end time, and the sale. And if it's available in the women's store, it looks like that. And then a query would look something like that, okay? And once we add in that filter query, everything works absolutely perfectly, okay? Perfectly, but not quite great, because there were a couple of holes, right? There were edge cases. And as engineers, we identified the edge cases, and the first thing we thought was, they'll never hit us, right? Within, like, you know, half a day of going into production, they smacked us across the face, right? So, you know, like, it turned out that the one thing that was just not ever possibly ever going to happen, happens all the time. So the way it works is this. If a product is actually available in a number of sales in the future, we have to figure out which one we're going to say is the start time and the end time, okay? And the heuristic we used was to say the earliest active window in time, okay? Which is fine, except if one of them is a private sale or a targeted sale, but one of the other windows is actually untargeted and public. And if we're in this danger zone here, it turns out that despite the fact that I would be allowed to see the product as a user, I won't be allowed to see it because it will be evaluated in the context of a private sale. Okay? You don't have to go too much into the details there, but basically it killed us, right? The other reason why it killed us is that the dynamic field solution was beginning to creak because our mobile team got really excited and they wanted to add search to the mobile application. And if we add in the idea of a channel, which is the mobile channel, coupled with the stores, we end up having a Cartesian product of dynamic fields, right? And already it doesn't even fit on one slide. It's all over the place, right? And you're going, this is really, really bad, right? So we nearly thought that the game was up, right? And then we just got it one day, right? It was like, let's actually stop indexing SKUs and denormalize yet again, right? Let's index the availability of a SKU at a moment in time, right? And once we did that, our model became easy, right? We simply said, here's a SKU, it's available at this time, and it's availability ends in this time, and here's the store it's on, here's the channel it's on, okay? What we found out was that the filter becomes much simpler, right? Realistically, like incredibly simpler, right? And a ton of code, all that code around deciding optimal availability windows in time, that all fell away. It was great, okay? The only thing we had to do, and it seems to work fine, right? We had to write a post filter in Solr to filter out multiple responses or duplicate responses, okay? Which is an order n activity. So we ended up with the following. We run our targeting, we dedupe, we apply the inventory function, we then sort, we then group, and then we get the response out, okay? At this stage, we added in a component on top there, the availability component, and what that does is it just makes it much easier to add all of those really awkward-looking filter query parameters. It adds them there within Solr, right? So that we kind of abstracted that away and made it much easier for people to use. Okay, so I'm doing okay time-wise. So just some thoughts on faceting and the things that we wanted to do there. So typically, the idea of a facet is that it's a filter using AND logic, okay? Like size is 36 and brand is Timber Island and color is red. But what users really want to be able to do is say, when I'm providing or multi-selecting on the same facet type, size, for example, then I want a logical OR, okay? Because realistically, I'm interested in the color. Let's say I'm interested in the brand Timber Island, but I don't know whether I'm 36 or 38, so I want to make sure that I can get this size or this size and the brand that I'm interested in, okay? I guess that was pretty straightforward. I mean, setting up the filter queries to handle ORs within a facet, that was fine, okay? And we use this idea of multi-select faceting. It's described in Eric's book, in terms of how you can tag your query, right? And then exclude the results of that filter query from the facet you're building. And that works out great. The only problem is that we ended up with this disappearing facet problem, okay? And this kind of surprised us. Here's what happens. You see, we're only interested in facets that are relevant to the query, right? So we set the min count on our facets to 1. Easy, right? However, if subsequent facet filters reduce the facet count to 0, then the facets effectively disappear, okay? Really simple example here. Imagine you have a search for shoes, you find 10 of the brand Aid and 5 of the brand Eric, and then 8 in black and 7 in red, okay? You then filter on red, okay? What you end up is with, what you want to have is that there are 7 of Aid and 0 of Eric and 0 of black and 7 of red, right? But because you set min count to 1, these guys disappear, okay? And that creates a problem because the initial facet model on our front end, all of a sudden there were values that were disappearing, right? So what we had to do is we had to create, we basically created a merge solution. So we actually, for every facet type like brands, we get the facets that actually happen in the query. And then we get the facets from the original query and all of the filter queries after it. And then we merge them together. And there's a simple rule there that says, for each facet, overlay the original counts with the values of the new count if present, or 0 otherwise. Okay? And that builds us up a really, really nice map of which facets are there and which are not. Okay? I really wish there was a better way to do this, because it feels wrong, it smells wrong, you know, and it doesn't feel like it's going to scale right. It works fine, you know, but I'm sure there's got to be a better way. Okay. A few minutes left. So I mentioned color was a complete nightmare, and indeed it was. So I actually lost a couple of weekends on this. If you're a girl, right, colors are so varied, right? And if you're a guy, it's just like pink, you know, or purple. Like, because really, you know, what color is cantaloupe? I mean, who buys something in cantaloupe? I don't know. But the color data that we were getting from our products, right, they had names like that, like cantaloupe, right? Or fuchsia. Like, what the hell is fuchsia? Right? Does anybody know what fuchsia is? You look at the girl. So it turned out, anyways. So fuchsia is most of the. Actually, I can't remember. I think it's kind of purple. Is it? A type of pink. A pinky, purpley, reddy color is what fuchsia is, right? What we needed to do is we're getting all these products, right? And they're coming in, and the name of the color is in there, and the color might be like Barcelona, right? Like, what color is Barcelona? I don't know. So basically what we did was we wanted to map those color names to a much simpler set of colors: black, blue, red, purple. Really, really simple, okay? So what we did was, and this was like a poor man's solution, we used a synonym file to map all of these really, you know, creative, artistic, and girly colors, right, into a much simpler space, right? So urobilin, for example, maps to yellow, right? That's just plain synonym file, okay? And then we used a stopwords file to remove things that we knew were not colors, like multi, right, or the word color, right? So we removed those things, right? And then finally, then we used a keep words file. It's not actually there. We only keep then the colors that are the 16 colors or whatever that are the simple colors, right? And what that does is it successfully maps around 70 to 80% of our colors, right? We're missing, you know, 20 to 30%, but that was as good as we could do, right? Works okay, but it's brittle, and what we want to do is move to like a swatch-based analysis. So actually take a swatch of the image, analyze the color, and then basically use that to determine the true color of the product. Okay. So other things we do: a hierarchical taxonomy faceting. Taxonomies are categories, right? I really do not like the way Solr does this, or rather the way Solr doesn't do this, right? What we had to do was encode, you know, like, so if you have a 4 levels of hierarchy here, Gilt, men, clothing, pants, we had to encode the path of the hierarchy into the label, right? Because a facet only lets you have a label and a count, right? And that was janky at best. I mean, it just feels so weird having to do that. So I would love it if Solr had a better way to do hierarchical faceting. Okay, and then there's a couple of other things that were hard as well, like size faceting. So we have you know, a number of different size types, like women's apparel, men's belts, whatever. Okay. And ordering those, like Solr basically gives you either count ordering or lexicographical ordering, right? Which makes a complete mess of the front end. So what you want is this 000246810212 addresses instead of 000102122468, right? It works out really bad, okay? And then even XSSML, blah, 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 rather than MLS, right? Also, even arbitrary orderings are important, right? Like if you have a brand that's really good and it begins with the word Z, and it's always going to the bottom of the brand facets, but actually it's the biggest brand right now, right? You want that to go to the top, right? So it would be great if there was a way to order some of that. So, all told then, yeah, the thing we add here then is just the faceting at the end, right? And like I said, there was a couple of, faceting things that we threw in there to get around a couple of problems, okay? Lesson 1, conclusions. Solr makes you happy, right? So our project went for about 12 weeks. We were, I think, in a dark release within 10 and a half weeks. We went live to almost the entire world, I think, in 14 weeks or something like that. The code itself is less than, I think, 4,000 lines of code in total, right? And we were all absolutely thrilled and delighted when we launched. So that's great. Solr makes you happy, right? That said, there were a number of times when I did utter the word, Solr, you bitch, right? A number of times, because there was a couple of things that tricked us up. But in general, everything was good, okay? Solr makes the business love you, right? So the business, when we A/B tested at 30%, our initial performance test said we could do 180,000 RPMs with a combined auto-suggest ratio of 5 to 1. It didn't actually break a sweat. I think at that stage, the bottleneck was the testing software more than anything else. I think we could have pushed further. Members who visit are 4 times more likely. The searchers are 4 times more likely to buy, right? So it turns out that this is really, really great. Incremental revenue, business pleads with us to release to 100%, and we happily accede. And we've been able to improve on the experience since then, and it's been absolutely great. Okay? Ton of stuff that we plan to do going forward, but I think I should stop now. I don't know, do I have time for questions, or? Let me just quickly say, the thing about the search is once you start it, it pulls you in, and there's a ton of great things that you can do. We realize there's a couple of problems. They're not really affecting customers. For example, the polysemy problem, I'm looking for a pink shirt. Well, actually, it turns out our users aren't looking for pink shirts. They're just looking for shirts, right? So they never really run into that problem, and when they facet on pink, it actually works out perfectly. So, but there are issues with the data we want to fix. One of the things that we will do is we will move in Gilt, we will move all of our listings to be based on this architecture that we've done. So every listing, not just keyword search, but category search and brand listings and sale listings. So we'll have everything over the same architecture. New SKU attributes, particularly for our kids business, very important. Solr 4 haven't even started yet, but ultimately we will have to obviously upgrade and move into there, and there's going to be some new things there. I think as well, there's bits that we didn't like, and I think trying to figure out a neater way or a nicer way to handle those hacky kind of things would be great. Would Elasticsearch have done what we needed here? It's an interesting question. I don't know. I think it probably would have been great, but I don't think we would have had the extension points that we needed to add in all of our filtering, and our inventory functions and all that stuff. Okay? So big thank you. There's the link if you want to get your $25. Thank you very much. It's been a real pleasure. Thanks.